Inverter with open collector. Open collector inverter. In this R4 Q4 D1 is omitted. Comparing from the figure, collector of the Q4 is kept open, and from there we take the output. Open collector inverter with the external resistor. To get the proper high-low levels, the output of the circuit and external pull-off resistor is connected to VCC. Q4 is off, the output circuit is pulled to high value through VCC. If Q4 is on, the value is grounded, so this TTL is inverted with the open collector gate is much slower than bottom of the pole output. Logic families are the bipolar families, MOS families, and BIMOS families. Bipolar families, it is deals with the BJT's bipolar junction transistor. So the circuit is made up with BJTs like NPN and PPN transistor. Then diode logic DL and resistor logic RTL, diode transistor logic DTL, emitter coupled logic ACL, and fifth one is the transistor logic. MOS family deals with the MOSFET, NMOS and PMOS transistors. We can implement logic gates using NMOS transistor along NMOS technology. Implementation of the logic gates using PMOS transistor alone is the PMOS technology. Most commonly used technology is CMOS, complementary metal oxide semiconductor logic. Combination of NMOS and PMOS technology more efficient, used for the large fabrication of the circuit. BIMOS is the logic family, is used for the combination both the bipolar and the MOS devices, also known as the BIMOS logic family. Input and output logic levels for the different gates. Input levels from the figure. For the input signal, logic 0 considers the 0 to 0.8 volt. The logic 1 is considers the 0 to 2 to 5 volt. Any voltage level between 0 and 8 volt, it will be considered as the logic 0. And any voltage level between 2 volt and 5 volt will be considered as the logic 1. Any voltage level coming under 0.8 volt and 2.0 volt will be considered as the intermediate region. Cannot identify whether it is logic 1 or logic 0. Output logic from the figure. 0 to 0.4 volt logic 0. 0 to 0.4 to 2.7 is the intermediate region, and the 2.7 volt to 5 volt is the logic 1. Logic levels will be different for the different families. Device type, the logic 0, logic 1. TTL 0 to 0.8 volt is the logic 1 is the 2.0 to 5 volt VCC. Outputs are A and B. Inputs are given to the reverse biased diode. Output is for Q. The VCC is connected to the resistor. CMOS will be the 0 to 1.5 volt, and then logic will be the 3.0 to 5 volt VCC. Example of the gate implementation: diode resistor circuit, tube input and gate. Case 1, A is equal to 1, B is equal to 1. Input A is given to the reverse bias diode, is given to negative terminal, so no current will flow through the diode. reverse biased. We will get a voltage equivalent to the VCC minus drop across the resistor R. It will be obtained at the output Q. So if A is equal to 1, B is equal to 1, output will be 1, Q is equal to also 1.